Um, good afternoon. This is my name is Dwayne Branch, and we're here with the Edge SIG, and we're gonna have Diego present to us today. And this should be a start of a lot of things for the AI Edge SIG to bring all the community together. Diego, you can take it away from here.
Okay, thank you so much. Let me start sharing my screen. Um, so yeah, about me, it's me again. I was a couple of weeks ago. So I'm Diego Alvarez. I'm technical marketing manager for Edge at Red Hat. And today we are going to be covering the second episode of this Computer Vision at the Edge series that we have prepared. So today we are going to see how to set up OpenShift AI and all the underlying components that we need to prepare to install this operator on OpenShift, um, on single node OpenShift. So just a quick reminder, this is the entire series. A couple of weeks ago, we talked about how to deploy single node OpenShift on bare metal, and also we saw how to do it on AWS. So on the right side, you can see the entire diagram for this series. This was the first chapter. So you remember what we were talking about on the last meeting. We saw that it could be great to for some use cases to move the data centers for training models closer to the edge. As when we run application at the edge, we have some benefits like low latency. We keep our data secure as we are not sending those information to a big data center over the network. So in order to be able to fit OpenShift into smaller servers, we decided to go for the single node OpenShift approach. So that's what we saw on the last episode. We deployed single node on a bare metal node with GPU. And also we saw how to do it also on AWS. So right now we are on the second episode where we are going to deploy OpenShift AI. So yeah, OpenShift AI, we will see it later, but it's the platform where all the different teams comes together to start building, training, and deploying and managing models. So OpenShift AI has some underlying operators that need to be deployed before. So for example, the first one will be the logical volume manager storage operator. When we create some resources inside OpenShift AI, those resources are created as pods. So we need to provide some persistent storage for those. We are going to do it with this operator as we are using single node OpenShift. So we will not use some other operator for storage like ODF, for example. So this is the one that we use for single node OpenShift. And also we are going to deploy another two of them, the node feature discovery operator that will take care of exposing the hardware that we have on this node, and also the NVIDIA GPU operator that will take care of managing the drivers and everything for the GPU card. So that's what we are going to see today. And for the next meeting, we will see how we can train the model on this OpenShift AI platform. We are going to label a custom data set. We are going to import some images so we can train a YOLO model. And in the future, we will see how we can, once we have this model working, how we can embed it into a containerized image so it can be pulled from the edge. So the edge device we have on the right side could be a simple small device with RHEL, and where we are going to deploy Microchip on top of it. But also for this demo, we try to recreate this edge device using OpenShift virtualization. And so this device will be recreated as a virtual machine. But if you have a physical edge device, you can follow the same steps. So yeah, you just need a real machine. You just need to follow the the Microchip documentation, and then deploy a couple of resources, a deployment, service, and route, so the application can run here. So about the application, we are building and deploying an application that recreates like a device that can detect and locate animals from a video camera. So yeah, basically you just take a video or a picture about an animal, and it will be recognized automatically, and you will get some information about that animal. So this could be interesting, for example, for some safaris, for example, instead of having somebody telling you what animal is, you can actually recognize them from your mobile phone, for example. So yeah, that's the idea. So I think we can start with the second episode. But before going into the demo, I will talk a little bit about OpenShift AI. So we will cover this in more detail in the next episode. But just a brief introduction: OpenShift AI is Red Hat's platform where all the different teams that are involved on the AI ML workflow come together to interact and to collaborate to build and train those models. So we have plenty of options inside this platform, starting from model development. We can use Jupyter Labs and Notebook to train the model, to import the dataset. We have an option to import a GitHub repository. So yeah, basically there you can train the model using your dataset. And once you have this model trained, you can serve it from another, that's another feature that OpenShift AI already has. So we can serve the model from there. We can monitor how this model is working. Another cool feature is that we can create repeatable pipelines. So it simplifies a lot of the process there, starting from training, but also for validating that the model is working correctly. So with pipelines, we can create those resources. And finally, as I said, we can create their workbenches project, and so everyone can contribute to build the model. So this is the introduction about OpenShift AI. We will cover it in more detail in the next episode. And with that, I think we can jump directly to the demo. So here I have the single node that we installed on the last episode. As we saw, the assistant installer gives you the web console URL and the kube admin and password. So first step will be opening the console, and you will be asked to log in using this kube admin and password. So I did it before this meeting. So this is the OCP web console. We can see that we go to nodes. We can see that we have just one single node with control plane, master, and worker capabilities. And yeah, we can start deploying those operators that we saw before. If we go to storage, we can see that there is no storage classes yet. In the operator section, there's no storage operator installed. So that's the first thing we will do today. We go to the operator hub, and we are going to search the logical volume manager storage operator. So it is as easy as clicking install and installing here. So here we can see an issue. Well, this is the problem that we are facing because I already did this demo before on this node. So probably we see here that that the operator was already deployed before, or at least some part of the components that it has. So let me see how can we fix that. To be honest, I don't know what's failing here. So let's continue with the next step. So I think the problem is because in my environment, I already have this installation done, and maybe there are some dependencies or conflicts there. So let's try with the next one. So the next one will be the node feature discovery operator. So yeah, we go to operators, operator hub, and we have both here. I'm going to select the Red Hat one. And let's see if this one doesn't fail when installing. So as I said before, this operator will take care of exposing the hardware. So basically, it's able to detect the GPUs in the physical node, and will label the node with the PCI vendor ID. So for NVIDIA, that PCI is 10DE. So once the operator is installed, we should see a label created on the node. So it looks like this one is working. Let's wait a couple of minutes. Okay, that's the output we wanted on the storage one. So yeah, once we have the operator, we need to create the operand. And in this case is the node feature discovery. So we can go to create instance. And here we can keep the default values again. So just click on create. And it will install the pods that we need to run this operator. So before that, let me show you, if we go to nodes, to the node that we have, and to the details page, if we look up for the PCI, it has already detected the NVIDIA GPUs. So that's great. That's because it's working correctly. So yeah, let's go to pods and the NFD namespace. And here we can see that all the pods are running. So yeah, as I mentioned, right now the node where the GPU is present, in this case, we only have one node, the single node. So it has been labeled with the PCI. Let me show you it again. Compute nodes details. And here you can see PCI 10D. That's the one that indicates that we have a GPU here. So that's all we need. So the GPU can be detected from this OpenShift. So the next step will be installing the NVIDIA GPU operator. So we need to go back to the operator hub, and we're going to install the NVIDIA GPU operator. Install and install again. So typically the operator doesn't take too long to have it installed, but the part that takes more of the time is when we deploy the operand. So yeah, now we have the operator, and we can create the cluster policy. So here we have lots of different fields that we can configure. You can see the list here that is quite huge, but the default parameters will work for this use case. So I will create this one, and it will start deploying all the pods. So we can see it from this pods tab, and this one is the NVIDIA GPU operator. So as you can see here, some of the pods are terminated, some other are initializing, and some other running. And this will take some time. So what we can do in the meantime is enabling the image registry. So here comes the thing. When we are installing single node on bare metal servers, the image registry bootstraps itself are removed in order to be able to complete the installation. So it's the user, the person that needs to enable the image registry again. So we can see this image registry component from this administration tab, cluster settings, clusters operators, and here we can search the image registry. And if we go to related objects, we can see the cluster configuration. And here is where we need to specify that we need to enable the image registry. So let me show you how to do it. We go to the cluster, and in the YAML, you can spot the field that we need to modify. Yeah, here it is. The management state, I don't know if it's too small or not, but here you have a management state sentence, and the value is removed. And what we need to do is modify this to manage. And also we need to add some storage, so all the images that will be used for this image registry can be stored. So if we go to the storage section, we can delete this, and we can add these sentences, PVC, and in another line, we need to add claim. So what happens here is that if we leave this claim value empty, OpenShift will take care of creating the PVC automatically. It will give it the name, and it will be created on the namespace that is needed. So for this purpose, we are going to keep it empty, as it will be completed automatically. But yeah, as we don't have LVMS storage, I don't know what is going to happen here. So yeah, let's find out together. So yeah, you just need to save the configuration. And you can see that, yeah, exactly. The management state is managed as we specified, and the PVC claim name has been complete. So at this point, if we go to the storage and persistent volume claims, we should be able to see something here. But as we don't have the, oh, well, we have something. Yeah, but we are not using LVM storage here. But yeah, let's continue with the instructions. So basically, the PVC is created, but we should see under events that there is an issue. Yeah, no storage class is set. So that's the problem with LVM storage. We create the storage class, and we specify that that's going to be the default one. So when the PVC is created, it will detect that storage class and will be specified on the PVC. So when we create this PVC, it will be automatically deployed and attached to the persistent volume. But yeah, we had the NVIDIA operator already being deployed. So let's see how this installation is going. Okay, we have some issues with my internet. Let's refresh the page. Okay, let's wait a couple of seconds. Okay, we are back. So as you can see, all the pods are right now running, and some other ready finished. So yeah, we have the NFD operator to expose the hardware, the GPU. We have the NVIDIA GPU operator, so the GPU can be used later in OpenShift AI. And the problem is that the storage one was failing. But let's continue with the next steps. Let's assume that we have also the LVMS storage operator installed and the image registry working. And the next one will be installing finally OpenShift AI. So let's go to Operator Hub, and let's see if we can install OpenShift AI. Okay, here it is. And we just need to click install and install again. So we should be able to access the OpenShift AI dashboard from this like the top part of the web console. So as you can see here, we don't have still that option, but it will show once we have the operator and operand deployed there. So yeah, as you can see, we need to create the data science cluster resource, and that's what we are going to do right now. Okay, we have the data science cluster option. Um, Again, we don't need to modify anything. It's quite simple. Just create. And you can see that the phase is progressing. Again, we can track the progress from the pods. Let's see. If we go to ODS application, we should see here the pods being deployed. Some of them are already being created. And also here, we can see that this OpenShift AI web console option has appeared. So let's try to open it. Maybe we need to wait a couple of minutes so all the pods keeps deploying. Let's refresh the page. And now we have the OpenShift AI login page. So to log in into the web console, we can use the same users that we have in our single node OpenShift. So in this case, I'm logging as Cube admin, but typically what you will do is creating some identity providers so you can set up the users, you can set up the permissions there. So yeah, you don't need to use the Cube admin user always. So this is the OpenShift AI dashboard. Here we have a lot of options. That one that I mentioned at the beginning of the call. The first thing we will do is create a data science project. So here is where all the resources tied to one specific model or task will be created. So this is similar to a namespace, for example. So we are going to create a new one called Safari and create. So right now we have this project, and inside this project is where we are going to specify what we want to deploy. So we have different options in order to train the model, to start building the model, and etc. The first thing you will need is the workbench. So you go to create workbench, and here you have like a form that you need to complete, and it will be created automatically. And you will have the Python libraries. You will be able to import notebooks there. So yeah, let's create it. We're going to use Safari, same name. Here we have different notebook images we can use depending on the requirements of the model we are going to deploy. So I'm using YOLO. We are not going to see how it works today, but it was the notebook image that works best with them is PyTorch, as we have some of the packages that we need here. So yeah, I'm going to select PyTorch, but also you can create your own images. So all you need to do is creating a container image. You pull it into a repository, and from the administration page, you can import that as an image and will be displayed here. So I'm going to use the PyTorch. That's one of the ones that we have already on the OpenShift AI platform. We have different versions. I will keep the recommended one. And here we can select the container size. So depending on your model, depending on your data set, you will need to select one or others. So in my case, I have plenty of space on this machine, so I will go for medium, but you can select other ones. Of course, you will see here the limits and the maximum request and CPU and memory. And here, if we did all the steps correctly, you should see the accelerator tab. So basically, if you look at this, you can see that we have the GPU and it has been detected thanks for the NFD and NVIDIA GPU operators. And it shows that it's compatible with this PyTorch image. So we are going to select the GPU card. And also you can select the number of accelerators. So in my case, I have two graphical cards inside that machine. So I can select two of them. But if you go for 3, it will be detected automatically that you don't have that extra GPU. So yeah, choose the number we are looking for. We have other options like adding environment variables that can be accessed from the notebooks directly. And also we need to provide the storage. That's the part that is going to fail at this point because, well, yeah, basically when you create a workbench, it um, it gets deployed as a pod. So if you want to save all the files, all the progress you have done there, you need to have some persistent storage. That's the reason why we try to deploy LVM as storage. And also, this is good because if you want to delete the workbench, the PVC is kept on the node. So if you create a new workbench, you can select the existing one, for example. So you have there all the documents and all the files that you need. But yeah, as we don't have any kind of storage in the node, we will try to deploy it, but it will fail. But yeah, just to show you that you can select the storage size. So if you are importing a data set, which is not the recommended way, as we have other options like using data connection. But let's imagine that we are importing the whole data set so we can give more storage to this workbench. But yeah, as I said, the recommended way will be using an S3 bucket data connection. So you can store there all your images and it can be pulled later from the notebook, but you don't need to keep it there in the workbench. So yeah, let's continue. We can create the workbench, and this is the part that is going to fail at this point, as we will not be able to create the storage, and also we couldn't enable the image registry as we were waiting for a PVC to be attached. But yeah, this is the reason why I had to enable the image registry, because when the workbench is being deployed, it will pull some images from this image registry. So that's the reason why you need to enable it before, so it can pull this PyTorch image. But yeah, as you can see, we don't have enough resources. We don't have storage on this node. But just in 2-3 minutes, if everything is configured correctly, the workbench will be ready. And all you need to do is click on open, and you will get to the Python environment where you can import the notebook and start working with your model. So maybe we can see it from the video that we already have on this blog post, just to show you how it looks like. But yeah, that was the main things that we wanted to show today. In the future episode, we can talk about other features that OpenShift AI provides, like, for example, pipelines that helps a user to create repeatable tasks. For example, training the model, validating that the model is working correctly. So you can create here your pipeline server, and with Elira, you can create your pipelines. We have another option for serving the model. Instead of using this containerized image, so it can be pulled from the edge, you can also serve models from this tab. And here we have the cluster storage that we could then create, and the data connection. So I mentioned that data connections are good for the data sets, but also when we want to store the model that we already trained, instead of pulling it into a registry, it's better if we can put it into a S3 bucket data connection, so it can be later served from the models page. And of course, always you can grant some permissions depending on the users. So yeah, from this platform, you can perform a lot of different tasks. So that's why different teams inside this AI/ML workflow can work together on this platform. So yeah, let me show you how this workbench should look like. So this here we have all the blog posts. I will share it with you later, but this is the one that we are covering today, the OpenShift AI installation and setup. So yeah, as you can see, the first step was the storage installation. Here you can see how all the pods are running, not feature discovery, NVIDIA GPU operator. We enable the image registry. As you saw, we had to add these storage PVC claim values and change the management state to manage. And finally, OpenShift AI. So yeah, well, actually, this is not covered here. It is covered in the next one. So let me show you really quickly how this workbench looks like. Yeah, here it is. So here we are creating the workbench. We are selecting the PyTorch image, the NVIDIA GPUs, and here we are creating the storage. So once we have it working, as you can see here, the image is being pulled from the image registry, and that's the reason why we enable the image registry. And you can launch and open this environment. So you log in with your Cube admin or your user, and you will get to the following page in the Jupyter Lab environment. And this is how it looks like. So here you can create notebooks. You can also import some GitHub repositories by cloning a repository, for example. And you have other options like showing the pipelines, etc. But yeah, in the next episode, I will have it working for you so we can see all these features working together. Yeah, that's all I have for today. Sorry because we couldn't see like the entire process as the storage was failing, but you get the idea. Installing operators is just as simple as the other ones we saw today. But yeah, that's all for today. Of course, here you have the link to the blog post and the video we covered today, and also the link to the index to other, so you can jump to other chapters. So yeah, thanks everyone. Let me know if you have any questions, anything you want to share.
Thank you, Diego. Are there any questions? Diego, I know we didn't get the storage portion up, but is there anything that tells you how much storage you need for implementation?
What do you mean when you want to create a workbench, for example? How do we select the storage we will need, for example? Or what was your question?
Does it come with any? If it's a small LLM, is it fine? If it's a big LLM, what is too big?
Okay, so yeah, OpenShift AI, when you deploy the workbench, you can actually monitor the GPU, the CPU, the memory, all these components. So there is no specific rule there. So probably the best thing you can do is start with, you can select the size. And if you see that maybe it's consuming more than what you provided, you can use those tools to monitor how the resources are being consumed, and you can edit the workbench and maybe add some, select the other size, for example. But yeah, it will depend on your model. It will depend on the number of epochs and trainings you perform there. Will depend on the data centers, the data, yeah, the data science, the data set size. So yeah, there is no rules here. You can start with a base medium if you have all the resources to have it. And then if you need more, or maybe you have enough power and you want to reduce it, you can use those tools inside OpenShift AI to change the resources. But yeah, I will show you how to do it on the next episode. Once we have the workbench running, we can see all these values on the CPU and memory.
Okay, awesome. Well, Diego, thank you so much for this presentation, and we look forward to all of your future presentations.
Yeah, thank you so much for having me here. And yeah, I will see you in 2 weeks with the next episode.